Hi guys, today we are doing section 3.5 to solve equations with variables on both sides. You're doing page 137. That's where it starts, number 1 through 33 odd. Okay, we're working out of the green book. Our quiz is switched to everybody for Monday, all classes, and book pickup can be done today or tomorrow. I emailed a schedule. So let's get started. I'm going to put this up for a minute. Please take a picture of this, pause the recording. These are the answers from last night's homework. Here's part 2. All right, now let's get started. Okay. So you don't need to rewrite the objective because I always have it set up on the first page. So section 3.5, solving variables on both sides. So when you have 2x plus 4 equals 5x minus 17, there's really no one way to begin. Our basic goal is to get the x's on one side and the constant term. So you've got variable terms. This is a variable term. Is like 3x, and you have a constant term. I use that language all the time. So I just want to make sure that you are understanding what we're saying. So a variable term versus a constant term. Constant term has no variable, and a variable term has a variable. So basically what we're going to try and do is get our constant terms to one side and our variable terms to the other. The method I always use is I keep my x term positive. Now, it doesn't mean that you're wrong. It's just that I try and minimize my negatives because that's where people make a lot of mistakes, including myself. I drop a negative. So I always start with my x term and I move it to the side. Remember, I have to do the inverse operation. I'm not going to divide this because I want to zero this whole thing out. I want to zero this out. So there's no 2x left on this side. So to zero it out, I wouldn't divide it, even though it looks like division. I don't want to split it and leave the x there, right? Then I'd be left with 1x. I don't want to do that. I want to zero it out. So I'm going to subtract 2x. Opposite of plus 2x is minus 2x. So I moved my x's over to one side, and then I'm left with 4 equals 3x minus 17. Now, notice what happened. I decided to move the 2x over because it kept it positive. I could have moved the 4 over. I could have moved the 17 over. I could have moved the 5x over. I go with my x's, what will keep it positive. If I can't, then oh well. Okay, now I'm going to move the constant terms over to the other side. So instead of negative 17, I'm adding 17. Okay, I have 21 equals 3x. Now I'm ready to get x alone. So I want to split the 3 and the x. So since 3 is multiplied by x, to get rid of just the 3, I would divide since it's multiplied. Dividing both sides, again, using my properties of equality. There we go. So here we can either call it the multiplication or division property of equality, because basically we're multiplying by a third to both sides, right? So we can call it the multiplication property, or you can call it the division property of equality. This here is called the addition property of equality, and this is called, also we can call this the addition property of equality or subtraction property. It's addition property of equality because we're adding negative 2x. Okay, but there's no one way to do this. So if we look at the PowerPoint, they're moving, what they did was exactly like I did. Okay, but let's look at starting with something else. How about if we move the 5x? Or what if we move the 4 to the right? Or what if we move the 17 to the left of the equal sign? So it doesn't matter, you'll see. Now I end up with negative 3 plus 4 equals negative 17. I'm subtracting 4 from both sides to 0 at that 4. And then I have negative 3x equals negative 21. Divide both sides by negative 3. And there we go. X equals 7. Okay, so it doesn't matter which side you move. We're going to move the x terms to one side, the number terms, constant terms to the other side. So variable terms on one side, constant terms, and that's when we split it. All right, so one more piece is added to these directions, and that is right here. Isolate the variable on one side of the equation. So pause your recording, go add that to your notes from the other day on one side of the equation. All right, so before we can do anything, I'm seeing we have some parentheses, so that means we need to do the distributive property first. So I'm going to distribute the 4 to the x, and I get, I'll do it here, 4 times x is a 4x, 4 times negative 2 is negative 8, minus 2x, bring it down. Then I'm going to distribute here, it's a 5x, and then I distribute here, it's minus 15. And now I'm going to combine my like terms, so that's a 2x minus 8 equals 5x minus 15. Now I want you to guess, what do you think I'm going to move first to keep the x positive? Well, hopefully you guessed 2x. Minus 2x minus 2x. It wouldn't be wrong if you moved anything else. Now I'm left with negative 8 equals 3x minus 15. I'm going to add 15. I'm adding 15. 7 is equal to 3x. We're dividing by 3, and x equals 7 over 3. Okay, pause the recording if you need to take those notes. All right, I'd like you to see if you can do this one. All right, let's check our work. So, there's a lot of distributing. The first time, we're doing 3 times x, we get 3x plus 6. Now notice, this is like a negative, but it's like a negative 1, so we have to distribute that negative 1. It becomes negative 2x and plus 4. Again, I have another negative to distribute. Negative 1 times 4x is negative 4x, and negative times 1 is negative 1. I'm combining my like terms, put my x's in a pile, that becomes 1x, and my constant terms, that becomes plus 10 equals negative 4x plus minus 1. Okay, now to keep my x's positive, I'm going to move my 4x. Okay, I'm left with negative 1 equals 5x plus 10. I'm subtracting 10. I'm subtracting 10. All right. And we are left with 5x. Where did I get 5? Oh, okay, because I see. We are left with 5x equals negative 11. Divide by 5. Divide by 5. And x equals negative 11 over 5. Let's double check my work. I have been known to make some mistakes. So let's go back. Let's see, what did I have? Negative 11 over 5. But their writing is much better. So we'll look at that. All right, let's keep going. So we're just adding variables and lots of parentheses on both sides. So when you have a parenthesis, like on the left side, we have a parenthesis within a parenthesis, we work inside out first. Now, I'm going to go here, I'm distributing, and I get a 5m, and here I get minus 30, equals 10. Do not do that subtraction. First, we have to distribute before we do anything. We distribute before we do addition and subtraction. We multiply first. It's order of operations when we simplify the side. When we solve it, we do the opposite. Okay, so it's 10 minus 4. Now we're going to work inside out. I'm going to distribute here. I get a 2m. I'm going to distribute here. We work inside out. Minus 14. And then I have a minus 5m. Now you have two possibilities. You could combine your like terms and then distribute the negative 4. Or you can just distribute the negative 4. Either way, it ends up being the same. You'll get the same answer. So I'm going to combine my like terms. In the parenthesis, I have negative 3m minus 14, right? That's the parenthesis. Notice, since I don't have a parenthesis within a parenthesis, I just switch to regular parenthesis. And now I'm distributing that negative 4. So we work inside out. So I get positive 12m and positive 4 times 4. 4 times 4 is 16. Carry the 1. It's 4 times 4, 5, 56, sorry. And it's positive. And then I have that 10, don't forget about that. I've distributed the 4 equals 5m minus 30. So I can probably combine those like terms, call it 66 plus 12m equals 5m minus 30. I'm subtracting 66. To move it over, I get negative 96. I could subtract 5m. I mean, usually I move my m's first, but I don't know. It's not going to hurt me if I don't. There's more than one way to do things. So what you choose, I'm never going to know what your first choice is. 96 equals 7m. Okay, divide both sides by 7. And we get messages. Okay, we get, it goes 13 times. Let's do that off on the side. Goes once, a remainder here. It goes 3 times. That's 21. And then I have, we can do 13 and 5/7, or we can convert that. So m equals, and notice it's negative 13 and 5/7. Or we can just leave it as negative 90. That's probably better. I don't know why I'm doing that. I just got sidetracked. Let's leave it as negative 96 over 7. Okay? Let's double check myself. Yep. All right. So when we're solving equations, there are 3 different scenarios that can happen. Let's look at the first one. So I'm going to move my x's over, subtract 2x, add 5, and I have 1 solution. That's scenario number 1. Okay? 1 solution. On B, let's distribute. I'm going to combine my like terms. 2x and x is 3x. And notice, both sides are equivalent. So when that happens and you try and get rid of an x, subtract 3x on both sides, what happens, you're left with 8 equals 8. When you have a situation where you eliminate the variable and both sides are equivalent, we say that x is any real number. It's an infinite amount of solutions. any number within the real number system, okay? So when you get a true statement, you end up, we say x is any real number, as opposed to the imaginary number system. So you're going to say any real number. You can say infinite solutions, okay? Sometimes when you're doing this, okay, we distribute, we'll combine our like terms, and then we end up here and we get a false statement. In that situation, we're going to say no solution. No solution. Okay? So we either have one solution, infinite solutions, or no solutions. You have three scenarios. When you end up and you eliminate the variable and the statement is true, if the statement is true, we would say infinite solutions or any real number. When you end up and the statement is false, you say no solution. And when you just get x equals a number, it's just that solution. All right, pause the recording and try the next one on your own. Now let's check our work. We distribute first, and we get 4y minus 8 plus 6y equals 7y minus 56 minus 30 plus 3y. I'm going to combine my like terms on each side. 4y plus 6y is 10y. And on the other side, 7y and 3y is 10y. Negative 56 and negative 30 is negative 86. So now I'm going to subtract 10y on both sides. And then, what are we going to say? No solution. It's a false statement. Negative 8 is not equivalent to 86. Let's try the next one. Okay, let's check our work. I'm distributing. I'm going to combine. Remember here, while I'm distributing, I'm doing 3. 3 times 4 is 12. 3k. Now here I'm distributing the negative 2. It's negative 6k, and then we have negative 8. I'm distributing 5k minus 15 minus 8k and plus 19. Okay, now we can combine like terms on each side. 3k minus 6k makes negative 3k, and 12 minus 8 is 4. And then on the opposite side, I'm combining 5k minus 8k is negative 3k, negative 15 and positive 19 is positive 4. I'm going to move the k's over, and we end up with 4 equals 4. So what are you going to say? X equals any real number. Infinite solutions, any real number. Okay? You can write one or the other. All right, our last piece is putting together what we did yesterday and today. Find a number that is 20 more than 4 times its opposite. Okay, what is my unknown? That's the first thing I want to ask you. So the first thing we're going to do is our unknown is find a number. So the number is the unknown, right? And now the number, let's say x, is my equal sign, and now I have 20 more than, with the word than, 4 times the opposite. Okay, so I have 20, more than is plus, and 4 times the opposite of x is negative x, right? So I'm going to have to, because it says than, I'm going to have to flip-flop this term and this term. So I think it's going to look like this. X equals negative 4x plus 20. Let's see in the PowerPoint. Okay. There we go. They flip-flopped it, just like I said. So the opposite of the number is negative x. If we call x the number, we had to flip-flop our terms, right? This comes over here, this comes over here, and there's a plus sign in the middle. Notice the equal and the x stay there. Okay, and now we're going to solve it. Let's move our x's to the left. How about add 4x to both sides? We get 5x equals 20. Divide both sides by 5. And we're left with x equals 4. And that, my friends, is the lesson.